back. Yes, we are looking at sequence status. Now, we looked at the first sequence, which had a little bit of a problem. It looks, I've gone through the other sequences, they look to me like they are very straightforward. So let's take along while we look at sequence number 2. Only now, okay. Sequence number 2, we need to have our software. We need to open, this is our previous scenario. Yes, solution to our last one. Let's go and say file, new. Then we want to create a new project, and it is sequence status still. Sequence status, and we are using the SS2, and it is the Delta PLC WPLSoft sequence 2. All right, I'll read out the sequence. You can write it down. I'll read it nice and slow. You can write it down. Let's maximize this. I'll read it nice and slow, so no one is lost. The sequence says, press start button, motor T rotates immediately. Then 10 seconds later, motor T stops. So you press start button, motor T rotates immediately. 10 seconds later, motor T stops, all right, while motor R starts. So motor T stops, but motor R starts. So press start button, motor T rotates immediately. After 10 seconds, motor T stops while motor R starts. A further 10 seconds and motor R stops as well. All right, a stop button, okay, it says 1. Imagine stop, it can be 1, so it says 1. Overload, I cannot accept 1. There's 2 motors, so I will not accept 1. All right, so if we stick with the theory, a dangerous theory situation where we use 1, I wouldn't accept it. I wouldn't accept it because any person would know that we don't break laws. All right, we don't break laws. So the law is some of these laws are actually there for what? For protection, for our protection and safety and security. Therefore, we cannot breach laws. Especially, you cannot breach this Health and Safety Act. All right, you cannot breach the Health and Safety Act, and it is unhealthy. It is unsafe to use one overload for 2 motors. So that one I will not accept. This will have to be 2 overloads. All right, let's see. You press the start button. So what we said we can accept 1 stop. So let's have 1 stop. X0 is our first stop. I put it as a normally closed. So this is stop. We can accept 1 there. In fact, let me take this. We're going to accept 1 emergency stop. So let's just say emergency stop. Let's go and say our stop is going to be X1. Again, another normally closed. X1. Okay. Then we say that is our stop. Of course, if you are joining us from here, you won't understand what we're doing. So you need to go back and do some of the earlier exercises on this Delta PLC or basics. We've been in it for a while now, so you need to go back and look at the other work first. You'd understand how we are loading now, and then this is our stop. Oh, okay, this is our stop, and then now I will not accept 1 overload here. So I'll come and say 1, 2. So this here will be the space for my what? For my latching. So I'll leave it blank. So now I can press my first overload. So again, it's a normally closed. Remember, in real life, it won't be normally closed. All right, it will be normally open because the overload is already normally what? But the overload does have a normally open part. It can be used, but a normally open contact. It can be used, but no. For this control part, normally the normally open is used for when the overload trips. Normally used for lights and whatever indicators, right? To indicate that there's an overload. So the normally closed is there. The overload is a normally closed contact. Is a pair of normally closed contacts. So now this is going to be X2, and this is going to be our overload. First overload. So this will be overload 1. Overload 1 for the first motor. Okay, then we can have a start for that first motor. Let's see, do we have two starts here? Let me see what's happening here before I do that. Do we have two starts? Press start button, motor T rotates immediately. Then 10 seconds later, so we don't have a second start, we only have one start. All right, so 10 seconds later, so what I'll do therefore is I'll put the two overloads in series, because I would like, this is me deciding that any overload should cut both motors. All right, but you get scenarios where they say an overload should cut its specific motor. You get a situation where they say any overload situation should cut both motors. So if I put them in series, I'll be saying the overload must will cut both motors. So what I'll do is I'll do this way. Going forward, if it's not indicated, I will treat it as one overload, any overload cutting both motors. But I will do an example where, let me first do that example. Let me first start with an example where each overload kills its own motor. All right. Let me therefore change this to a start. Let me change this to a start and say it's going to be normally open. Okay, I'm going to call it the start. All right, so okay, so now I'm gonna have, what am I starting? I'm gonna start motor 1, which is Y0. Oh, and then this is called the, what is it called? Motor T rotates immediately. So this is motor T. This is motor T. Okay. So the moment I hit start, motor T must rotate immediately. So what does it mean? It means motor T must latch itself. So motor T must latch itself. So let's come and have a normally open from motor T, which is Y0. Okay, this will, all right, so I don't need that one for now. I will see if I need it. The vertical line must go. So now I say okay, so this starts immediately, and then, so as you can see, if I hit that, the motor thing will start immediately. Now if I hit the start, a motor T will start immediately and latch itself. Then 10 seconds later, motor T stops while motor R starts. So what happens is that 10 seconds later, so it means I must have a timer here. TMR, T0, K is 100 because it's 10,000 seconds, 10 times that. So now I don't want it there, I prefer it right here. I don't want it all the way there in case I need to put other elements. I don't want to. I'll delete everything here. All right. So I'm just, yeah. So now this is 10 seconds. After 10 seconds, this here must start a second motor. So what I'll do, okay. So I did need that one after all. The line that goes down. Now this line that goes down is going to be for T0. A normally open LD T0, okay, which is actually what? 10 seconds delay timer. So 10 seconds. All right, 10 seconds, and this one here starts a second motor. Does it? The 10 seconds later, motor T stops while motor R starts. So motor T stops. What does it mean? We come and cut. We must come and cut. Let me put it there. Normally close from the first timer, LTI, from T0. Okay, that one will cut the first motor while engaging the second motor. The second motor is Y1. So out Y1. So while that timer will break that, it will energize that, and then Y1 will run. But because breaking here also breaks the supply to the timer, this timer will let go. So we need to latch. So we need to latch so this one can continue running. So this is a normally open LD from timer 1, from Y1 we're latching, from output 1, output, which is, by the way, that is motor R, right? This is motor R. If I remember correctly, it was motor R. Okay, so that is just motor R latching. So what we then do is we say latch. So what happens further? Let's see. It says here, need this. Okay, after motor T stops while motor R starts. Okay, and further 10 seconds, motor R stops. So we need to start this with a timer. We start that with a timer, which is TMR T1. Again, they say 10 seconds again. After further 10 seconds, motor R stops. So we say 10 seconds, which is K. 100 again, because the cost is 100 multiplied by the T1 is between T0 and T63. Therefore, it's also 1 millisecond. 100 millisecond resolution times K100. That gives you 10,000 milliseconds, and that will be another 10 seconds. All right, now that was just a reminder. And then this here will stop itself. We'll come here and say, after I'm done counting, I'm going to cut power to that Y1. So this will be an LTI because it's closed. Instruction set LTI, and this is T1. After the timer is done counting, it's another 10-second timer. So we will state that it's another 10-second timer. And now let's see if we are done. Okay. So press start, motor T rotates immediately. Yes, if you engage X2, that line will be closed. It will let itself while it's timing out. It is Y0 is running. Yes, that is satisfied. Then 10 seconds later, motor T stops. So after counting out, it will come and break here. That's satisfied. And then while motor R starts, after that 10 seconds, it engages here. That line is closed. Yes, Y1 will engage. That's R starting. A stop button. Okay, a further 10 seconds, motor R stops. So this will count down 10 seconds and come and break there. So that is fine. We are super. A stop button, there it is. It will break that entire thing. And when you stop, it will break that entire thing. We can accept one for that scenario, but I refuse for an overload for only one overload for two motors. So each motor, Y will have its own overload. So we'll call this. I'll come there and say X3 will be there. Okay. Load doesn't a closed one, it's an overload. So X3, which is overload 1. I wanted to cut only the one motor. Okay. Overload 1 cuts one motor. Alright. That will be overload 1. And X4 will be also a closed LTI. X4, and it cuts the other one. Remember that I could have put them in series with these ones here and made them cut both motors. Remember here I've made it If there's an overload here, it will only cut this specific line. There's an overload there, it will cut. So each motor has its own overload. So this one is set according to motor T's, what call this overload 1 is set according to motor T's current, running current, and then overload 2 is set according to what? Oh, I didn't say overload 2 here. Overload 2 is set according to motor R's running current. So this is overload 2. Okay, so that is a simple scenario. This is the first case, and let's test it. I will not worry about all the so-called errors for now. So what I'll do is I'll come here and say, let's set on. As you can see, oh, I didn't run. I did not put it on run mode. We're on stop mode. So let's come and put it on run mode. Then we come and say, let's set it on. Now you can see as it counts out, that one immediately running. After 10 seconds, it must stop, break here while it's engaging here so the other motor can run. After a further 10 seconds, okay, something is wrong here. Oh God, I did not release my start. I did, but I think I missed it. It was this way. It's like I pressed my start. It's like I never let go of my start. So after 10 seconds, that one stops, this one starts. Okay, I had not released my start, so it kept re-energizing. Okay, so after a further 10 seconds, this must come and cut itself. All right, so they both stopped. All right, let's run it again in case people were lost. Set on. I must release this. I press and release. Set off. So it's counting out. After 10 seconds, this will disengage while engaging that. So this one, the first one stopped while I is now running. After a further 10 seconds, it will break there, and you can see it works well. All right. So this is one way of doing it if each motor is going to be cut by its own individual overload. All right. In the future, I'm going to assume a scenario, if it's not said, I'm going to assume a scenario where any overload will cut both motors. As long as there's an overload, the whole sequence must stop. All right. So if your scenario says that, so all I'll do is change this a little so that I need 1, 2. So all I'll do is come here and do this, put this down. Okay, come and put this. I want to move everything one space to the one place to the right. So I'm moving this line 1 down there. All right, now I'm moving my T0 there, LDI. This is what I'm moving, T0. Okay, and I'm moving my T1 there, LDI, T1. Now the overload, I'm gonna change that to the start, T0. I'm gonna say LD, T0. Okay, then I'm gonna latch, I'm gonna remove that line there, delete. Then I'm gonna put my motor here, LD Y1, and I'm gonna latch around T0 there, and I'm gonna say come down there. Then I'm gonna come up there and say U X4. I've eliminated X4, haven't I? So I will need this to be X4. I'll come here and say this is X4. Let's first come here and say X2 comes here. Okay, this one comes there, Y0 comes there. Okay, and I close this there. What I'm basically doing here is I'm moving the overload into the series line. So I'm coming here now and I'm gonna say I've moved T0, so this is gonna be X5, X4, no? add the normally closed of X4, which was overload 2, and we change this to normally closed overload 1. Okay, let's just say LDI, and you say X3. This is the other overload. Okay, so we are done. All you do now is come here and say delete this, delete the line, the vertical line. Oh, I didn't know why I did it. Okay, let's delete this, delete the vertical line, delete the vertical line, delete, and delete. Oh, I didn't delete that vertical line on top there. Delete vertical line. I thought I deleted the vertical line. Okay, delete that, and delete this, and delete the vertical line. Okay, what have we done? We moved the two overloads in series with the other ones, with the emergency stop and the stop. All right, but then this is the overload from the one motor, the other overload. So you can see if this is the overload situation, it breaks the whole circuit. This is the situation, it breaks the other circuit. Okay, but I cannot accept one overload when there's two motors mentioned. It shows ignorance. All right, the rules don't allow that. All right, now what you see here is this is the start. When you start, that one will run. In fact, let's just run it. I don't see any mistake, so let's just do it. The only difference now is that any overload will kill the whole circuit. Okay, so now I don't care about errors for now. All right, okay, if I hit my start, first run, yes, let's go and say run, set on. You can see our first motor runs immediately. There is Y0, and the counter is counting. When it's done, it's gonna break there and energize there, starting that motor which it just did now. And as you can see, after it counts out, after this timer counts out, it is gonna break that, and it still works. So it's the same thing. Only difference here is that in the first case, each overload cut its own motor. All right, now any overload situation will cut both motors. So this is a safer way to operate, but sometimes we are required to have an overload cut its own individual motor. So I hope you like this. If you did, hit the like button there. Please tell us where you are on the comment section. All right, and if there's any advice, any suggestions, please feel free to say them on the comment section as well. And then otherwise, those who are new, please subscribe and then turn on the notifications so that you can be the first to know when we have when we've got some new stuff for you. All right, till we meet again. Ciao, ciao.